In evaluating 2x squared times 3x to the negative fifth, we know that we can change the order of multiplications so that we can do 2 times 3, which is going to give us 6, and then that's going to be multiplied by the x squared times x to the negative fifth. Now, people pretty much remembered the rule for multiplying numbers of the same base with different exponents. You add the exponents so that x squared times x to the negative fifth will be x squared, or x to the x to the 2 plus negative 5, put it that way. Okay, 2 plus negative 5 is negative 3, so we have 6x to the negative 3. Now, what is x to the negative 3? There's some confusion on this, and this is not unexpected. If you're a little rusty with your algebra, it's really easy to get confused when it gets to negative and fractional exponents. The two often get confused, and as a matter of fact, just as in my applied calculus class in our review, people wanted to say that might be the cube root of x or the 1/3 power of x or something like that. In fact, x to the negative 3 is reciprocal of x cubed. So this gives us 6 times the reciprocal of x cubed, which can just be expressed as 6 over x cubed. Now, to avoid confusion about these laws, it's best to understand their consistency, where they come from. If we accept that x to the a times x to the b is x to the a plus b, then we can apply that and figure out what x to the negative a ought to be. Let's do that as follows. Okay, let's do x to the a multiplied by x to the negative a. What does that give us? Well, using this law, that's going to be x to the a plus negative a. Not law, it's more of a rule, but it's a good rule. Okay, x to the a plus negative a is, of course, x to the 0, and what's x to the 0? Now, I got a lot of blank stares when I ask that. You have a rule that people pretty much memorize. It says any number to the 0 power is 1. But there's a reason for that rule, and we're going to talk about that in a minute. But let's accept for now that x to the 0 has to be 1. Well then, x to the a times x to the negative a is equal to 1. So we could write the equation x to the a times x to the negative a equals negative 1. How do we solve that? Well, we solve it. Yeah, let's see, part of my equal signs kind of gotten obscured there, so let's make sure it's visible. Okay, to solve this equation here, x to the a times x to the negative a equals 1, we just divide both sides by x to the a. Then the x to the a is going to, dividing x to the a by the x to the a is going to give us a 1 times x to the negative a, just plain old x to the negative a. On this side, we're going to have 1 divided by x to the a. So it follows that x to the negative a is 1 divided by x to the a. Why does x to the 0 equal 1? Well, x to the 0 equals 1 because x to the a times x to the 0 should equal x to the a plus 0 by this rule again. If we accept this rule, we've got to accept this. And x to the a plus 0 is just, and boy, I wrote a bonehead thing there, didn't I? Let me fix this. Okay, I wrote a there instead of x to the a. I was focused on the exponent and talking at the same time and attending to students, and just got careless with what I wrote down. Hope you do your algebra more carefully than I'm doing mine right here. Okay, anyhow, that gives us x to the a. So we conclude that x to the a times x to the 0 equals x to the a. So multiplying x to the a by x to the 0, we get x to the a. Now, when you multiply something by something else and get the same thing you started with, then what's that something else? Well, the only number that you can multiply another number by and get that other number is 1. That means x to the 0 has to be 1. So there's a good reason why x to the 0 is 1 and why x to the negative a is 1 over x to the a. It makes this consistent. Okay, it's the only way to have this rule and be consistent with your notation. Okay, well, now let's consider fractional exponents. This didn't really come up in the problems as I stated them, but this is a good time to think about it. Let's just take the example x to the 1/3 multiplied by x to the 1/3 multiplied by x to the 1/3. If you accept the adding of exponents when you're multiplying two numbers of the same base, then this has to be equal to x to the 1, since 1/3 plus 1/3 plus 1/3 is 1, and of course x to the 1 is just x. And what does that mean? That means x to the 1/3 is the number which, multiplied by itself 3 times, gives you x. That means that x to the 1/3 is the cube root of x, because that's exactly the meaning of the cube root. It's the number that you would multiply by itself 3 times to get your original number. So there are reasons for these rules of exponents. X to the 1 over n is the nth root of x. X to the 0 is 1. X to the negative a is 1 over x to the a. All these are required to make this consistent.